Good afternoon, my dear student. Today we will discuss about Norton's theorem and its application. So far, we have covered Thevenin's theorem, maximum power transfer theorem, superposition theorem, Okay. So in today's lecture, we will try to understand Norton's theorem and its application, especially to solve different circuit theory problem. It is used to solve different circuit theory problems. When we have covered the topic Thevenin's theorem, that time I told you that there are three cases arise to solve circuit theory problem using Thevenin's theorem. First one is the circuit may consist of only independent source. Second case, the circuit may consist of in both independent and dependent source. And the third case, your circuit may consist of only dependent source. Okay. So for Norton's theorem, we will face these three cases, that your circuit may consist of independent source only. Second case may consist of independent and dependent, both independent and dependent source. And third, only dependent source. So let me write this thing. Your circuit, we will face three cases to solve circuit theory problem using Norton's theorem. Case 1, circuit consists of independent sources. Case 2, circuit consists of both independent and dependent sources. And case 3, only circuit consists of dependent sources. And here we have considered only resistive circuit. You know that these theorems, either Thevenin's theorem or Norton's theorem, is applicable for both AC and DC circuit. AC and DC circuit, that means your circuit consists of DC source and resistances, or your circuit may consist of AC source and impedances. Okay, capacitor, inductor, whatever. That means reactive circuit. Okay, you know that Thevenin's theorem give us an equivalent voltage source. On the other hand, Norton's theorem give us an equivalent current source. So let me tell you what is Norton's theorem. If you know Thevenin's theorem, then you can easily understand Norton's theorem, because Norton's theorem is nothing but the equivalent representation of a circuit in terms of a current source and a resistance which is connected in parallel to the current source. Okay, so that means Norton's theorem tells us that a two-terminal active circuit can be active circuit consists of several energy sources and resistances can be replaced by an equivalent circuit having a single current source in parallel with a resistance. Okay, so let me repeat what is Norton's theorem. Norton's theorem states that a two-terminal active circuit consists of several energy sources, maybe voltage source or current source, and resistances. We have considered here resistive circuit can be replaced by an equivalent circuit having only a single current source and a single resistance which is connected in parallel to the current source. Okay, now we will solve few problems for better understanding the Norton's theorem, and we will consider the cases for independent source only, for both independent and dependent source, and final one is only dependent source. So let me show you one simple problem. You see, so from this analysis we can say that Thevenin's theorem and Norton's theorem are actually in 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 duality. Actually, they are dual each other. I mean, we can determine the Thevenin equivalent circuit from Norton equivalent circuit or Norton equivalent circuit from Thevenin equivalent circuit. Okay, they are dual in nature. I mean, they satisfy the duality property. So now you see a very simple problem. A circuit consists of a single voltage source and two resistances. Your task is to draw the equivalent Norton circuit. So you see that to determine the equivalent circuit, we will follow some steps. We will follow some step. If our circuit consists of only independent source and resistance, then we will remove first we will remove the load resistance or the resistance across which we need to calculate the voltage or through which we need to calculate the current. So for this case you see AB terminal, okay, already load resistance is removed. The step 1, if you remember the steps required which are required for Thevenin's theorem, that steps you can use. First you remove the, for independent source, remove the load resistance or the resistance for which we need to calculate current or voltage. After that we will calculate the short circuit current. You put a short circuit across between the terminal A and B. Step 1, remove the load resistance or any other branch element for which we need to calculate current or voltage. Remove the load resistance. Second step 2, compute the short circuit current, okay. You place A, or you short terminals A and B are shorted, okay, shorted. Then step 3, you calculate short circuit current, you calculate. Then you calculate step 3, equivalent resistance for this circuit, equivalent resistance, or Norton's resistance. Similarly, by replacing all sources, calculate the equivalent resistance or Norton resistance by replacing all energy sources by their internal resistance, okay, resistance. And finally you draw a circuit having a current source which produce short circuit current, equal to short circuit current in series with the Norton resistance, okay. So for this circuit you can calculate, if you make short A and B, these two terminal, if you use a short path here, then you can say that this R2 resistance is sorted out, so therefore the current which will flow through this short path will be equal to I short circuit current equal to nothing but E divided by R1, because since R2 is also shorted, okay. If you short if you place a short path between AB terminal, then we can say that resistance R2 is also shorted. So therefore our circuit has only one voltage source E and one resistance R1. Therefore the short circuit current will be equal to E by R1. Now you tell me what will be the Norton resistance for this circuit, okay. Rn, you can write Rn equal to, you replace all sources by their internal, you replace this voltage source by its internal resistance, that means 0. Therefore you will get a circuit having two resistance R1 and R2 in a parallel connection, therefore we can write R1 equal to Rn equal to R1 into R2 divided by R1 plus R2, okay everyone. So therefore we can say that the Norton resistance is the ratio of the product of resistance R1 and R2 and the sum of resistance R1 and R2. So now you can draw the Norton's equivalent circuit by considering the short circuit current as a current source in parallel with Rn resistance. Okay, Rn resistance. So therefore, to draw the equivalent circuit, Norton equivalent circuit, or to obtain the current through any element or branch for a given circuit using Norton's theorem, or voltage we will follow some step. If the circuit consists of only independent sources, then we will replace the branch element for which we need to calculate current or voltage. After that, we will calculate the short circuit current. Later on, we will replace all independent sources by their internal resistance in order to calculate the Norton resistance. One thing you see that Norton resistance is same as Thevenin resistance. Okay. So if you know the Norton resistance and current, then you can calculate current and voltage for other branches. Now give you I will give you a new problem. You solve it yourself. Similar type problems. Okay. Here R1, R2, E are unknown. Okay. The values of this parameter are unknown. In next problem, you will see that the values of this parameter or these elements are given. Voltage source 100 volt, resistances are 10 ohm and 15 ohm and 10 ohm. Okay, so a circuit you see here, a voltage source, DC voltage source is connected, equal 100 volt. This is one resistance 10 ohm, this is one resistance 10 ohm, and this is 50. This is a T type network. You see, so far we have discussed about T type network and Pi type network, star network, delta network. So this network is nothing but a star network or T type network. This network is connected to a voltage source, DC voltage source having voltage 100 volt. Now you calculate, you draw its equivalent, it's not on equivalent circuit. So first you calculate the short circuit current. You use a short path, you short this AB terminal and you calculate the short circuit current. Okay, and after that you calculate the Rn Norton resistance. So you see, if you short AB terminal, then you will get a circuit having a voltage source 10 volt and a parallel combination of a series combination of 10 ohm resistance and parallel, the resultant resistance of this parallel combination 10 ohm and 15 ohm. So therefore we can write the current, short circuit current I is nothing but 100 volt divided by 10 ohm, okay, plus parallel combination of these two resistance 10 ohm and 15 ohm. Everyone see that, everyone look at the picture, look at the figure, and then you short terminals A and B, put a short between terminal A and B. After putting the short between terminal A and B, then you can say that the circuit is nothing but a circuit having a DC voltage source and a resistance 10 ohm is connected in series with the resultant resistance of the parallel combination of resistance 10 and 15 ohm. So therefore we can write current I, short circuit current, equal to 100 volt divided by total resistance of the circuit 10 ohm plus 10 parallel 15. So therefore we can write here we can write here 100 volt divided by 10 plus 10 into 15 divided by 10 plus 15. Okay, so this equal to nothing but 100 divided by 10 plus 150 divided by 25. So now you tell me what is the value of short circuit current. 100 divided by that means you will get how much? 6 6. So 10 plus 6. So you will get ultimate 100 divided by 60. This amount of current you will get ampere. Okay. So this amount of current 100 by 16 6.3 ampere. Okay. Thank you, Saiba. Next you tell me what will be the value of Rn. Rn. Norton's resistance. Now you calculate the value of Norton resistance. So you see the Norton resistance, if you short the 100 volt by its internal resistance 0, shorted, then you will get 15 ohm resistance is connected in series with the resultant resistance of the parallel combination between 10 ohm and 10 ohm. So therefore we can write 15 plus 10 parallel 10. So therefore we can write 15 plus 10 into divided by 10 plus 10. So therefore we can write 15 plus 10 by 100 equal to 15 plus how much? 15 plus 100 means 0 0.1. The 15.0.1 15.1 ohms. Okay, so you will get 10 ohm is Rn. Okay, let me check. If you short 15 in parallel 10 into 10. Okay, right. 100 divided by 20 equal to 15 plus 5. Therefore, you will get 20 ohms. 20 ohms. Okay, thank you everyone. Yes, 20 ohm. 20 ohms. 20 ohms. Now, let me give you another problem. Okay, if you face any difficulty to compute the short circuit current or Norton resistance, write your confusion or doubt in chat box. Okay, if anyone face any difficulty to solve this problem, write your confusion in the chat box. Now let me give you another problem. Okay, so you see the circuit for the present problem. The circuit consists of two sources. One is current source and another one is voltage source. Okay, now you solve the given problem using Norton's theorem. You see, the circuit consists of two independent sources. One is voltage source, another one is current source, and few resistances. Your job is to calculate the value of current which will flow through this load resistance 15 ohms load resistance. Using Norton's theorem, calculate the current flowing through the 15 ohm load resistor in the circuit shown below. All resistances are in ohms. Now you tell me, how do you solve this problem? You can solve this problem using Thevenin's theorem or other approaches, superposition theorem. But in this problem, it is mentioned that you solve problem using Norton's theorem. The theorem, Norton's theorem, is mentioned in this problem. Now you tell me the value of current which will flow through the 15 ohms load resistance. Okay, so what you will do to solve this problem? So you see, there are two sources. So first you remove, step 1, you remove the load resistance from your circuit. You remove the load resistance 15 ohm resistance from your circuit. So step 1, everyone first remove, step 1, remove the resistance, remove the load resistance 15 ohms load resistance from A and B terminals. Okay, then you use a short path. You use a short path, that means you short the terminal A and B. Short the terminals and then short then terminals A and B, A and B are shorted. Okay, so everyone first everyone remove the load resistance from AB terminal and then short the terminals A and B. Okay, next you calculate short circuit current for short circuit current I dash for 30 volt voltage source, for voltage source only, for voltage source, plus I for current source use superposition theorem, use superposition theorem. Okay, so to calculate short circuit current for two independent sources, we can use superposition theorem we will calculate current for voltage source, and then we will calculate current for current source. Now you tell me what will be the value of short circuit current for this given circuit. Short circuit current. Okay, tell me, anyone, what will be the value of short circuit current for this case? When current source only present, that time you tell me, and when voltage source only present, that time you tell me what will be the value of current. So we can write I dash the current only for voltage source. How much you will get for voltage source? You will get how much current? So you see that if you sort out, if you open this source, this is infinite. It has infinite resistance. Then you will get a circuit having this series resistance 4, 6, and 30 volt. So therefore we can write 30 divided by 4 plus 6. So 4 plus 6. Sorry, 30 divided by 4 plus 6. It's correct. We can write it. So we can write 30 divided by, if we consider 30 volt voltage source and replace the current source by its internal resistance, that means infinite, that means open, so we will get a circuit having 30 volt voltage source in series with resistance 10 ohms. So therefore current equal to, for voltage source, 30 divided by 4 plus 6, that means 3 ampere. Now let me calculate the current for only current source. Everyone solve the problems, calculate the short circuit current yourself and compare the result with my result. Okay. Now let me calculate the current I for current source only. So if we consider this current source, then this source will be replaced by its internal resistance, that means 0, short out. Okay. So therefore the current through 6 ohm resistance is equal to the current through the short path. Okay. So therefore we can write the current through this resistance, 6 ohm resistance, will be equal to how much? Will be equal to, you see, this 4 ampere current is divided into two parts. One is flowing through 4 ohm resistance and another one is flowing through 6 ohm resistance. To calculate the current through 6 ohm resistance, we will use current division rule. So by using current division rule, we can write total current, the current into opposite uh, branch resistance, that means 4 divided by total resistance 4 plus 6. Okay, this is the approach using current division rule. You write here using current division rule. The 4 ampere, if you short out 30, then you can realize that 4 ampere current, this current is divided into two paths. One part is flowing through 4 ohm resistance and another one is, this is short actually, short, and then 6 ohm resistance. So the current through 6 ohm resistance is equal to the current through short path. So therefore 4, this is the total current into opposite branch resistance 4 divided by total resistance. So we can write this equal to 4 into 4 16 divided by 4 plus 10, so equal to 1.6 ampere. 1.6 ampere. So everyone solve the problems yourself and compare it with the result nodal analysis, then also we will get done. Yes, Saiba, you can use also nodal analysis. You can consider the voltage at point C or C equal to V, and you can calculate using KCL. You can use nodal analysis also, no problem, or superposition, whatever. Okay, so there are so many theorems or laws available to solve circuit theory problem. You can use any one, but one thing you remember, that you must choose or select theorems or laws which will help you to solve the problem easily. I mean, it will take less time or less computational complexity. So the therefore the short circuit current equal to, we can write 3 ampere plus 1.6 ampere, 3 ampere plus 1.6 ampere equal to 4.6 ampere. Okay, so short circuit current, therefore the current is, calculate the current flowing through 15 ohm resistance. So current is equal, not, okay, I had made a mistake. You see, 3 ampere current is flowing through this path towards clockwise direction, but 1.6 in anti-clockwise direction, so you make it negative. So therefore you will get ultimate current equal to uh, 1.4 ampere. 1.4 ampere. Okay, so everyone try to understand the solution of this problem. You see, short circuit current is the difference between the current for only voltage source and the current corresponding to only for current source. You see, the current corresponding to voltage source will flow through this short path in the clockwise direction. On the other hand, the current due to 4 ampere current source flow through this short path in the anti-clockwise direction. Therefore, the total current or resultant current which will flow through load resistance will be equal to the difference between these two current value, 3 minus 1.6 equal to 1.4 ampere. Don't sum up these two current values, because you see the direction of current are different. One is clockwise direction and another one is in anti-clockwise direction. So everyone must remember the direction of current which flow through the load resistance or any branch element. Okay, if current for individual sources will flow through the load resistance or any branch element in the same direction, then we will sum up of those current values. If they are not in the same, they are not flowing in the same direction, then we will take difference or we will subtract one from another. We will subtract current in anti-clockwise direction, in the direction of anti-clockwise, from the current flow in the direction of clockwise. Okay, in the clockwise direction. Okay, so if anyone face any difficulty to understand the solution of the given problem, please write your confusion or doubt in the chat box, or please let me know. Okay, now we will solve another problem for which the circuit consists of both independent and dependent sources. Whatever we have discussed still are still the circuit consists of only independent sources. Now we will solve a problem where our circuit consists of both independent and dependent sources. So everyone, look at the next figure. Look at the next figure. You see the problem is the circuit associated with this problem consists of two sources. Not two sources, consists of three sources. Among these three, one is independent voltage source, another one is dependent voltage source, and the third one is dependent current source. 5I is a dependent current source, voltage dependent current source. VAB is a current dependent voltage source, and 2 volt is an independent voltage source. Now you calculate, you draw the equivalent Norton resistance, Norton circuit. So to draw equivalent Norton circuit, first we will calculate Norton resistance and short circuit current. So you know, to solve such type of problem where the given circuit consists of both independent and dependent sources, we will consider we will consider or we will calculate open circuit voltage, short circuit current, and finally we will calculate Norton resistance. Rn equal to short circuit current voltage divided by open circuit voltage divided by short circuit current. Let me repeat it. To obtain Norton's resistance, we will calculate open circuit voltage VOC and short circuit current IAC. If we know these two things, then we can calculate Rn equal to open circuit voltage divided by short circuit current. Okay. So first you calculate open circuit voltage and short. So you see the open circuit voltage is nothing but the voltage drop across 20 ohm resistance. This voltage VAB, the voltage drop across terminal AB. So open circuit voltage is nothing but the voltage drop across A and B terminals, which is equal to the voltage drop across 20 ohm resistance. So now you calculate open circuit voltage and short circuit current for this circuit. Okay. So open circuit voltage equal to how much? You tell me what will be the value of open circuit voltage. VOC equal to 20 into current through this resistance. So current, how much current? You see 5 ampere current flow in opposite direction, that means 5 ampere currents. Actually this current flow 20 ohm resistance, so we can write minus 5I, opposite direction. So 5I, this amount of voltage, okay, will drop across VAB or 20 ohm resistance. Everyone try to understand the solution of this problem, or you can solve yourself using other approach, and finally you compare your result with the result obtained, okay, with the with my result. Okay, so you see the voltage drop across AB terminal is nothing but the voltage drop across 20 ohm resistance. The voltage drop across 20 ohm resistance is nothing but resistance into current. So what is the current for the resistance? You see this current actually going in opposite direction. So therefore the current through 20 ohm resistance is equal to minus 5I. So we can write 20 into minus 5I volt. Now we can write we can write we can write minus 100I, and VOC is nothing but equal to VAB. Okay, we can write it VAB. So you just write this is equation 1, equation 1. Now you solve short circuit current ISC. What will be the value of short circuit current for this circuit? Short circuit current, if you make a short between AB terminal, then you can say that this is also shorted out. Okay, this is also shorted out. The VB equal to 0. VB equal to 0. So then you can say the current I short circuit current is nothing but minus 5I. Short circuit current is nothing but minus 5I. If you short this path, then this resistance is sorted out. So therefore this current will flow through this circuit, through this path. So therefore I short circuit I short circuit current equal to minus 5I. Everyone try to understand the solution of the present problem. You see, if you short out this path AB, then this is sorted out. So the short path current is nothing but this current, but this current in opposite direction. Therefore, it will be minus 5I. Short circuit current is minus 5I. Okay, minus 5I. Now you tell me what will be the value of minus 5, what will be the value of I? If you consider this circuit, this means left hand portion of this circuit, this one, then you can write you just consider this closed path. So by applying KVL, applying KVL for closed path or closed loop, okay, at the left portion of the circuit. If we apply KVL for closed loop at the left portion of the circuit, we can write we can write we can write uh, 2 volt 2 volt minus 200 I 200 I and VAB equal to how much? 0. 0 minus 0 equal to 0. So from this we can write or I equal to how much? 2 by 200 ampere equal to 1 by 100 0.01 ampere. Okay, 0.01 ampere. If you consider this closed path and if this is sorted out, that means VAB equal to 0. This VAB equal to 0. So you can write 2 volt into 2 volt minus 200 I plus 0 equal to 0. Okay. So therefore I equal to 2 by 200. That means 0.0 ampere. Therefore short circuit current equal to minus 5 into 0.01 equal to how much? Minus 0.05 ampere. So the short circuit current equal to minus 0.05 ampere. Now you calculate VAB. RN equal to VOC by ISC. ISC is already obtained. So we can write VAB divided by ISC. So now you calculate VAB. VAB equal to minus 100 I. So minus 100 I 2 minus VAB equal to how much? VAB, if you consider, now your objective is to calculate VAB. So like 2 minus 200, 2 minus 200 minus VB by 100 equal to minus VAB equal to minus 2 volt. So you calculate it yourself, you will get VAB equal to minus 2 volt divided by minus 0.05 ampere. So you will get ultimate 40 ohms. Everyone see the VAB equal to minus 2 volt and ISC equal to minus 0.05. Therefore RN equal to 40 ohms. 40 ohms. Okay. Now you open. This is VAB. Let me explain this thing. It is open. Through calculate VAB, we will open this VAB. Here you will get VAB. So okay, now you can write. Now you can write what you can write 2 minus 200 I minus VAB equal to 0 minus VAB equal to 0. Now you can write, if you apply KVL when it is open, then you write this. Let me write here when so 2 volt minus 200 VAB equal to 0. Here we have considered this is open, that means VAB exists here, not equal to 0. So therefore VAB you can write, or we can write, or 2 minus 200 200. I equal to how much? I equal to how much? VAB by 20. I equal to how much? Minus V by 100. Means this one. I equal to how much? I VOC V 2 minus 200 minus VAB equal to 0. I equal to, you can write minus VAB by minus VAB by 100 minus VAB equal to 0, or we can write here VAB equal to minus 2 volt, minus 2 volt. Okay, minus 2 volt. If you write here the 202 VAB, 2 VAB plus 2 VAB minus VAB, so VAB equal to minus 2 volt, and I equal to nothing but VAB by 100, VAB by 100, because we have got here I equal to VAB by 100. This one. From here you can write, or I equal to VAB by 100. From here we can write I equal to minus VAB by 100, and we replace I in terms of VAB. So ultimately we will get minus 2 volt. Okay. So everyone try to understand the solution of the present problem. Where is you just use the basic concept of KVL, and you use the steps required to draw the Norton's equivalent circuit. First, what we will do to calculate short circuit current or RN, you know, for a circuit having both independent and dependent source, we will calculate, at first we will calculate short circuit current and open circuit voltage to obtain Norton resistance, because Norton resistance Rn equal to open circuit voltage by short circuit current. For this case, you see that AB is the open circuit terminal. So the voltage drop across VAB is equal to the voltage drop across 20 ohm resistance. We know that voltage drop across 20 ohm resistance is nothing but the product of resistance 20 ohm and the current flow through this resistance. Then you see that 5 ampere current will flow through this resistance, and this current direction is opposite, therefore we will take negative sign. If you remember the sign for voltage drop or sign for apply voltage, okay, so minus, so therefore VAB equal to minus 100I. Now you see short circuit current, if you apply a short path between AB terminal, then short resistance 20 ohm will be sorted out. So therefore the short circuit current is nothing but minus 5I, opposite direction, and you know the value of I equal to 0.0 ampere, which is calculated from the closed loop by applying KVL from the closed loop which exists at the left hand side of our circuit. Okay, we got short circuit current. Now our objective is to calculate open circuit voltage. So if we apply KVL at the left hand portion of the circuit, when our AB terminals are open, then we can write 2 volt minus 200I minus VAB equal to 0. That means 2 volt. This supply voltage is dropped across 20 ohm resistance and VAB, because this is dependent source. So therefore we can write 2 minus 20I minus VAB. Now we can replace I in terms of VAB, because our objective is to calculate VAB. We know that I equal to minus VAB by 100, which one we got by placing a considering the voltage drop across 20 ohm resistance. So therefore VAB equal to minus 2 volt. Now you can calculate Norton resistance by taking ratio of minus 2 volt and minus 0.05 ampere. Therefore you will get 40 ohm resistance. Load Norton resistance. Value of Norton resistance is 40 ohm. So therefore we can draw the Norton's equivalent circuit by using a current source which can produce current 0. How much? 0.05 ampere minus 0.05 ampere, actually 0.05 ampere. You will change the direction of the current source. Okay, that means towards down, not clockwise direction, just you take in anti-clockwise direction. Then you connect a resistance in parallel with this current source having resistance value 40 ohms. Okay, now if you have any doubt, any confusion to solve problem using Norton's theorem, Thevenin's theorem, superposition theorem, maximum power transfer theorem, KCL, KVL, nodal analysis, mesh analysis, if anyone has any confusion or difficulty to understand those theorems or laws, whatever we have covered so far, please let me know or you write in your chat box. In next class, we will discuss about remaining 3 theorems such as reciprocity theorem, compensation theorem and Millman's theorem. Okay, in next class we will try to understand the remaining 3 theorems including reciprocity theorem, compensation theorem and Millman's theorem. Okay, so after completing these 3 theorems we will proceed for new topic, that is transient analysis or Laplace transform. Okay, so we need at least at least one more class to complete the theorems. In next class I will discuss about remaining 3 theorems: reciprocity, no, compensation and Millman's theorem. You read, you carefully read these theorems, and next class we will solve some problems. MTA syllabus, Arijit, actually MTA, I think MTA will start from the first week of October, tentative date, I don't know the exact deadline. So whatever we will cover before that. Okay, that means at the end of September, whatever topic we will cover, that will be the syllabus for MTA exam. Okay, and don't worry, I will give you some sample question for MTA exam related to those topics, whatever we will cover before MTA exam. Okay, so everyone means expect that the syllabus for MTA exam will be the topics whatever to be covered before at the end of the September. That means before first week of the October. That will be the syllabus for our MTA exam. Okay, any doubt regarding Norton's theorem, Thevenin's theorem, superposition? Okay, one thing, these theorems are applicable. Remember that are applicable both for AC and DC circuit. If in your exam the circuit consists of impedances and AC sources, then you can calculate the Norton resistance or Thevenin resistance or Thevenin voltage or Norton short circuit current. Okay, so therefore for both AC and DC circuit and also resistive and reactive circuit, these theorems are applicable. So all I suggest all of you solve more problems related to AC circuit and DC circuit or reactive circuit and resistive circuit. If you face any problem, any difficulty to solve those problems, please let me know, or you send a mail to my email ID about your confusion or doubt. Okay, so I suggest everyone solve more problems related to these topics in case of AC circuit and DC circuit for both. Okay, thank you everyone. Let me stop today's lecture here. I will give you an assignment in the assignment in this week. I will give you an assignment whatever topic we have covered. Okay, related to the problems related to the topics whatever we have covered. Okay, I will give an assignment in this week. Okay, thank you everyone.